So today we're going to go over hot gas differential valves. So first, we're going to go to machine room, troubleshoot it, see what I'm dealing with, and then we're going to go back to the pen and paper. I'm going to explain it. So today we got grocery freezer, some other stuff. Let's fix it. So if we take a look in here, you can see it's iced up on the back. So there's something wrong with the defrost. Let's go figure it out. Also, you do want to check the door switch. So obviously, door switch is right there. I press it in, turns on, press it out, turns off, on, off. Good to go. Okay, so what we're gonna do now is we're gonna put it in a manual defrost. So we're gonna go up to it, A1, gonna go, service. We'll go defrost operation, and you're gonna sign in. So it's manual on now. So now we're gonna check to see if it's in defrost. So we can see it's in defrost, hot as heck. It doesn't seem, we want to feel below the valve because we want to make sure that there's not, bleeding back to the system. Everything seems okay. Now, I'm also going to check to make sure the defrost differential valve is doing its job. Wow. So you can see currently that right here should be 20 psi higher than over there. Why? Because on this back side of this hot gas differential valve, it's going to slow the flow, raise this up 20 psi, and then you have your hot gas header that's going to go out to your cases and defrost your cases. If it's not 20 psi higher, then over here, it's not going to be able to overcome your liquid pressure, and maybe I'll draw like a diagram or something. So anyway, this hot gas differential valve's not doing its thing. So we're going to take a look why. You can see that it's kind of working. It's working okay. But realistically, if your hot gas doesn't have that 20 psi differential, you can look at it and kind of go, we fixed it. We're good to go. But in reality, that should be melted off in like we're talking, that'll melt off in like 2 or 3 minutes with hot gas. It's just that snowy buildup. So it's not working. So what I'm going to do is I think we'll manually turn the valve on and we'll see what it does. Because I took off the solenoid. The way that it works is when the solenoid's engaged, it will not hold back pressure on this side of the valve. Why? So defrost will still work when, in case we lose the ability to communicate with the controller right there, okay? So if we come over here, right, we see this pilot line is open, verified the pilot line's open. Come over here, took off the coil, so now there's no way of me getting confused on whether or not it's doing anything, right? So now if we look at before the valve, we follow that down, we come up here, the hot gas header's over there. We have our yellow hooked up to the hot gas header, and then we have our red hooked, if we follow after the valve, it's hooked up right there. So there should be about 20 to 30 psi difference between those two values, and there's not. So all right. So what I did was, I took off the thing. It's been running. Also, you can verify. Just make sure, let's say there's a large circuit in defrost. It might be causing an issue. There's nothing in defrost. I would know because it would highlight it in yellow. So nothing in defrost. There's no pressure differential. Okay, the solenoid is physically taken off. But let's just say on the off chance this valve might be different. So we got our solenoid magnet, we'll pop that on there, okay? And it should start building up kind of right away. Doesn't do a thing really, okay? If we shake it in and out, won't do a thing. We gently tap the side of it with a wrench, it's not doing nothing. Now there's only one test that we can do, is that we can physically try to adjust that adjustment stem and see if it does anything. Now we will remove the cover and we're going to screw it in and see if it does anything, if it adjusts the pressure differential at all. Weird. So if you look at that stem there, that's a manual operating stem. If we look at it, it actually says auto operation turn stem in, manual operation turn stem out. So that stems all the way out. So it stands to reason that it's actually put into manual mode now. I'm honest, I don't really know what that means, but we'll take a look. So I manually stem this one in a couple turns, no change. So I'll try to manually stem in the back one and see if we get any changes. And if nothing's working, then nothing's working. We gotta write up the valve. Here we go. That back stem was, for some reason, now it's starting to hold stuff back. So we're gonna neck this down just a smidge. That's a bit aggressive for my taste. Now you can hear that's holding back stuff. Now with that back stem in, you know, most of the way, it kept turning, but I just felt uncomfortable. It kept going. I don't know why it didn't seem to have a hard stop, but it's working, so I'm not gonna go any further with it. So we can see right now this is 35 above, so that's a bit aggressive. So we're just gonna, you know, turn it to the left a little bit. We're gonna try to keep it around 30-ish, but a little bit low, up a bit. There we go. Now you can see a little bit more. There we go. No. Yeah, whatever. 25 to 30. That's good to go. So you can see now that that's at the right thing. Now watch this. I take my solenoid magnet. There we go. Now that's a proper functioning valve right there. So it ends up that the manual bypass was open all the way. So don't know why that's the case, but anyway. Now that this is working, we have to do our actual final test, which is, you know, put the case in question and defrost. Put a couple cases in defrost and see what happens. So as I mentioned earlier with the grocery frozen case, come down here to your grocery frozen. I could physically feel it's feeding hot gas to the grocery frozen. I was like, oh, it's feeding hot gas. But then when I go down there, it wasn't actually defrosting. So you can see that just after one defrost, that's how it should look, clear, at least from the snowy stuff. But anyway, as you can see, after we fixed the hot gas differential valve, ripped a bunch of things through a defrost, everything's out of alarm except that one side of the grocery freezer, and it'll be out of alarm in a couple minutes. So kind of how everything works and why I started off with looking at this master hot gas valve. So the way that this son of a gun works is, right, so we have this, you know, compressor 1, compressor 2, compressor 3. Now I know it's not as great as my colorful ones, but you know, I'm waiting for my dispatch to call me back, so I figured I'd make a video. Right, so we have this whole, you know, 200, so we have the master hot gas valve. What does that valve do? It holds back pressure. Okay, so your discharge comes out of your compressors, okay, and this master hot gas valve will hold back whatever you set it to. So in the video, I set it to about 25 to 30 above what we want our discharge going into our condenser to be. So if I want my discharge to be 180, our hot gas, our master hot gas valve is going to hold back 25, which gives us 205 psi, right? So what would happen? Well, the discharge comes, hits this master hot gas valve, goes through, goes to your condenser, into your receiver. Now we have your liquid header. Out of your liquid header, it comes down here, goes to your TXV. Now across your TXV, it's 20 psi. We're just going to use a low temperature application. So we're just going to use 20 psi as an example, right? Goes to 20 psi, and then you have your evap coil, okay? And now from your evap coil, it's going to go all the way up back to your rack. And now this is your suction header right there that's connected to the suction side of all your compressors, right? And that's your EPR valve. So how this hot gas works is this master hot gas valve holds back 30 psi higher than this liquid pressure, right? So we have this hot gas header, we have a pipe that goes off, and we have that pipe go into our suction side just above the EPR. So when our system says we want defrost, this EPR valve will close, this hot gas valve will open. Now 205 is greater than 20. So what will happen is this hot gas will rapidly flood into the suction side, and that suction side will go into your evap coil. Now when it's in your evap coil, Now, when it's in your evap coil, what's it doing is it's absorbing it's actually, the cold from around it is absorbing the heat energy inside that coil. So that ice that's on the coil is absorbing the heat energy by the hot gas, and it's condensing that hot gas down, right? So we're turning this evap coil into a condenser. Now what happens is when it gets to the other side of the evap coil, we have this line here. I accidentally drew it there, so I scribbled it out. Now this line is a bypass line. EXV bypass line. So what happens is we get to here with our 205 psi pressure, and it's going to follow this line, and now there's a check valve. And that check valve only allows flow this direction, right? So in order to get flow in that direction, we need to overcome 180 psi. That's why the master gas valve holds it back. So then we overcome this, and it actually feeds this liquid refrigerant that we just made by passing it through the evap coil. We feed it back into the liquid line, and it'll actually, in a lot of cases, it'll make its way all the way back to this liquid header right there. Okay? So that's why we have to hold it back over there. So when I arrived onto the store, okay, I noticed that not only, so if I were to look at my like floor plans for the store, right, I noticed that I had this freezer right there that was icing up. I had a whole 30 doors of ice cream right there icing up. And then I had a couple doors of frozen food icing up, right? And then I went into here and I saw that it was just that snowy ice. I ran it through a defrost and saw that it didn't defrost. So if I have a theory, this is, all this doesn't have good airflow. This doesn't have good airflow, right? This doesn't have good airflow. It seems like everything's icing up. Then more than likely it's not the hot gas solenoid right there. It's more than likely the master hot gas defrost valve that's actually isn't holding back the proper pressure. And that's why my first inclinations was to check this 205 psi, because when I ran this case through a defrost, I went over and I checked this hot gas solenoid, and I could tell that it was feeding hot gas into here. Because if this hot gas differential valve isn't working, right, this master hot gas differential valve, if that's not working, this will still flow to your evap coil, because this would be 180 psi because it's not holding it back because it's not working, right? So it would still flow into your coil, but when it makes it to that check valve, it's going to stop there. And if it stops there, what's going to happen is all that hot gas is just going to lower in temperature. It's going to absorb all that. Well, it's going to lose all that heat energy. It's going to defrost it a little, but it's not going to be as effective if you have a flowing new stream of hot gas. Think of if you run your sink with steaming hot water into a bowl and you just leave it there, versus if you constantly run that steaming hot water, you know, on whatever you're trying to heat up. If you let's say you put a package of meat in that bowl, that package of meat is going to absorb all the heat energy from that bowl, you know, and then it's going to, you know, that bowl's going to be lukewarm in like an hour. But if you just let the hot water run, that bowl's going to be piping hot in an hour, and that meat's going to be defrosted, probably going to be cooked a little bit. You probably shouldn't do that. It's not going to taste as good. But here's the same principle, where if you have the hot gas running through the evap coil, it's going to heat it up better. It's going to do a better job of de-icing. So that's why I addressed it the way that I did, and I knew to check the master hot gas valve. I just want to explain. Quick point of clarification. The reason that was a red flag to me for the master gas valve is because the individual solenoids will only affect individual cases, where the master hot gas valve will affect all of the cases. So when I saw that multiple cases were icing up, it led me to believe that there's an issue that was affecting the entire store and all of the cases, and not just one particular case. Okay, so that solenoid only controls one particular case. So I would have started off with the master gas valve and then maybe moved into the controls, because it was icing up the entire store together. Okay, I just wanted to make that very clear. Explain that. I think I'm going to put this in at the end, so you can watch the troubleshooting first, and then I can go through and explain. That's why I'm doing it. Anyway, hope you learned something. If you know something about it, comment below. Remember, I'm just a dude on the internet with a phone. If you know something more than me, comment below, please. I would love to learn it. I would love for other people to read it and learn it too. I don't shy away from criticisms. I want this to be a place where people can learn. So please like, subscribe, and that's how you do it. Have a good one.